Hello, this is Mr. Flatness, and today we'll be looking at multiplying fractions. In our first slide, we're going to model what it means to multiply two fractions together. So taking a look at our problem here, we want to find out what is 1/4 of 3/5. The word of is a word that is very significant here. The word of in a problem like this means we need to multiply. Before we begin that algorithm, I want to show you with a picture what it means to take 1/4 of 3/5. So, to the right, you'll see that we have a rectangle. Okay, and so I'm going to kind of trace. Here we got a rectangle, and the rectangle that we have is going to represent the fraction 1/2, or the whole number. Okay, and what I did with this fraction is I separated this fraction into 5 equal parts. So there's 5 equal rectangles, and you'll notice that 3 of those rectangles are shaded. So this particular diagram here represents the fraction 3/5. So what I'm going to do then is take this 3/5 that I have, and I'm going to divide it into 4 equal pieces, because I want to find out what 1/4 of it is. So this 4 in the denominator tells me I'm going to take this shape and split it into 4 equal pieces. So in doing so, I will take it and split the diagram in half once, approximately, and then I'll split the halves in halves. And my lines aren't perfect, but basically that's the idea here. I've split that into 4 equal pieces. And so now I want to know what 1/4 of it is. So I'm going to color in one of these, shade this in. So there's 1/4 of the whole shape there. And so our answer that we're going to be looking for would be where the two shadings come together. So if you look at that, I'll use a different pen here. Where my shading of the 1/4 and where the original shading of the 3/5 was, that represents these 3 little equal squares right here. 3, 1, 2, 3. So that's 3 pieces that are shaded in out of a total of, and now what I need to do is count out how many total equal little tiny rectangles we've made. So that would be, the rectangles here go 1, 2, 3, 4 across, and 1, 2, 3, 4, 5 down. So 4 times 5 is 20. So 3 out of 20 would be shaded in. So 1/4 of 3/5 would be 3/20. Now there's another way to do this too. We talked about how the word of means multiply. So what we're going to do here is show you with multiplication that I can do the same exact thing here. So we said the word of means multiply. So 1/4 times 3/5 is what we're going to do to solve this particular problem. And in the next slide, I'm going to show you now the steps on how to multiply two fractions together. So on this slide, it gives some very important information, ones that you should write down in your notes so that you could study it. Because we're taking a look at now, if I want to find the product of 2 or more fractions, we know that that's going to be equal to the product of the numerators divided by the product of the denominators. Okay, so I have a fraction here, a over b, and I want to multiply that, and this dot means multiply, to a fraction c over d. So when I do that, I'm going to take a times c, and I'm going to put that as the numerator, and then I'm going to go b times d and put that as the denominator. So then that would be my answer in the end. A times c divided by b times d. A big thing here we also have to remember, and there's a rule here that's very important, b or d in this particular case, they are not allowed to be 0. You may not have 0 in your denominator if you're working with fractions. So, and then the final thing is we simplify our answer. So let's go back to that original problem. We wanted to find 1/4 of 3/5. So what I'm going to do is I'm going to take my 1 times my 3, top times top. I'm going to take the bottom times the bottom. So 4 times 5 would be 20. So then I'm going to look at to see if my numerator and my denominator can be divided by a common number or by a common factor. And looking at that, 3, the factors of 3 are 1 times 3. The factors of 20 are 1 times 20, 2 times 10, and 4 times 5. So they do not have any other common factor except for 1. Therefore, I know that the fraction 3/20 is in simplest form. Let's try some examples, shall we? Here we have 3 different examples of multiplying fractions together. So we'll go ahead and take a look at our ruling here. So again, I have 3/7 times 2/9. So I'm going to go top times top. So 3 times 2 would give me 6. And then I'm going to take 7 times 9, and that's going to give me 63. Now in looking at 6 and 63, I know that that is a fraction that can be reduced. As both of them, I can divide them both by 3. So I can reduce that. I can take 6 divided by 3, which equals 2, and I can take 63 divided by 3, and that would be 21. So 2 over 21 would be my answer in simplest form. Now, there's another process that we can use to help us that would make that easier. A lot of people struggle sometimes with trying to simplify 6 over 63. So you'll notice here at the bottom it says cancel when you can. The term cancel is talking about taking a look at numbers that are diagonal from another. So 3 and 9 are diagonal from one another, and 7 and 2 are diagonal from one another. And so what we want to try to do is see if we can find a common factor that we can divide them by. So in looking at 2 and 7, I do not see a common factor that I could divide them both by. The factors of 2 are 1 times 2. The factors of 7 are 1 times 7. So the only number I could divide both of these by is 1, which wouldn't change those numbers. But the other diagonal pair, 3 and 9, I know that the factors of 3 are 1 times 3. I know the factors of 9 are 1 times 9 and 3 times 3. So what I can do is I can divide these both by 3. And when I do that, 3 divided by 3 is 1. And 9 divided by 3 is 3. Now that I've canceled that part, now I can multiply across the top and across the bottom like I did in my rules here. So 1 times 2 would give me 2, and 7 times 3 would give me 21. So that is a process called canceling, which I highly recommend because it makes doing the problem quicker and easier. Let's take a look at the next problem, shall we? We have 4/5 times 25 over 36. So again, looking at these kind of numbers, I'm going to look at diagonal numbers and try to cancel by looking at a common factor. So I'm going to start with 4 and 36. I see that they're both even, so I know that I could factor out a common 2. 2 is a factor of 4, 2 times 2. 2 is a factor of 36, 2 times 18. However, I also know that 4 is a factor of 4, 4 times 1. And 4 is a factor of 36, 4 times 9. So what I'm going to do is divide them both by 4. 4 divided by 4 would give me 1. 36 divided by 4 is going to give me 9. Looking at the other diagonals, 5 and 25, I see that they have a common factor of 5. So I'm going to divide those both by 5. 5 divided by 5 is 1. 25 divided by 5 is 5. So multiplying across the top, 1 times 5 would give me 5. And 1 times 9 is going to give me 9. So my answer in simplest form would be 5/9. In our final example, you'll see that I have three fractions that I'm multiplying together. 6/7 times 5/18 times 4/15. So it doesn't matter how many fractions I have in a line, because I can still use this process of canceling so that I can work with smaller numbers in the end. So looking at diagonal numbers, I have 6 and 18. I can also compare 6 with 15. Those would also be considered to be diagonal from one another, just like 7 and 5, and also 7 and 14. I can also talk about 18 and 14, and 5 and 15. So any kind of numerator and with working with a different denominator that is not a part of the whole original fraction is fine to do. So I'm going to be looking at canceling here. So I'm going to look at, first of all, I see 6 and I see 18. And I know that they both share a common factor of 6. 6 times 1 is 6. 6 times 3 is 18. So I'm going to divide those both by 6. 6 divided by 6 is 1. 18 divided by 6 is 3. Then I'm going to take a look at the numbers of 5 and 15. I see that they share a common factor of 5. I can divide 5 divided by 5, which is 1, and 15 divided by 5, which is 3. The final diagonal numbers that I see here are 7 and 14, which they have as a common factor of 7. So 7 divided by 7 is 1, 14 divided by 7 is 2. Now that I've done as much canceling as I can, now I'm going to multiply all the numbers across the top. 1 times 2, which is 2. And then I'm going to multiply the numbers across the bottom. 1 times 3 is 3, times 3 is 9. So my fraction in simplest form, my product, would be 2/9. Feel free to rewind this part of the video as many times as you can to see all the different processes that I'm using so that it will make sense to you in the end. The final slide we have for you is an application slide where we're going to use the concept of multiplying fractions and use it in a word problem setting. So, 2/3 of Mr. Perez's students play an instrument. Of these students, 3/5 are male. What fraction of the class is male and plays an instrument? So looking at that, we have some important words that we would want to take a look at. 2/3 represents a fraction of Mr. Perez's students that play an instrument. 3/5, we're talking about a fraction that represents how many are male. Then I have this word here, of, and we talked about how of means multiply. So to set up this problem, I'm going to take 2/3 and I'm going to multiply that times 3/5. And that's going to give me my answer of how many boys will there be that play an instrument. So I can multiply it. Again, I'm going to look at diagonals to cancel. 2 and 5, they do not share a common factor, but 3 and 3 do. I can divide them both by 3. So now I'm going to multiply across the top. 2 times 1 is 2. And 1 times 5 is 5. So it says now to answer correctly, 2/5 is my answer. What fraction of the class is male and plays an instrument? We would say 2/5, and then we would say of the class. And that's how you apply your knowledge of how to multiply decimals in a word problem. This concludes the lesson on multiplication of fractions. Again, I'll encourage you to rewind it as many times as you need to see the different methods that I used in order to solve these problems effectively. Have a great day.